Yeah. Channel is on.
Okay.
Yeah. You can just I'll hand over to you once I briefly introduce you.
Okay.
Good morning, all. We are entering into the third day, day 3 of the faculty development program in fluid dynamics. I hope all these days, the previous 2 days sessions went on very well. We had 3 lectures in day 1 and 3 lectures in day 2. Unfortunately, one resource person could not present his paper as he was not feeling well. That's the reason. Anyway, if he is all right, certainly I'll give him some slot on different date to present his ideas on fluid dynamics. So today's first session is a session is given by Dr. Buddhi Sapkota from Tribhuvan University, Nepal. He has completed his research PhD from Tribhuvan University, Nepal. Then he has got double degree. He has completed his MA Sociology from Tribhuvan University, MSc Maths in Tribhuvan University. So he is a right person for us, I believe. He has worked in RR campus of Tribhuvan University in Kathmandu since 2007. He has presented papers in more than 20-25 conferences, India and abroad. Sorry, not India and abroad, Nepal and abroad. So he has visited US. He worked India. He visited China. He visited Sri Lanka. He visited. So almost he has visited more than 10-12 countries to present his papers, and he is advisor to so many administrative position. He is advisor to so many administrative bodies of Nepal, government of Nepal, like Sundar Nepal Sanstha, Surket, then BNA, etc. He was the program coordinator there. He was the team leader in one SSMP project. So he is he has I don't think the within few minutes given to me, I cannot read out all his achievements, I can say. So with this, I welcome you, sir, for today's session. Actually, he was out of station. So he requested me. Then only it means with my under my pressure, like he came here and he he is presenting now. Otherwise, he was out of station. Just to present the paper, he came to Kathmandu and he is presenting now. Thank you, sir, for your. I am sorry I have disturbed you. I have not disturbed you, I believe. So thank you for accepting our invitation. Thank you, sir. I'll hand it over to you, sir. Thank you.
Okay. Thank you so much, sir. Now I'll share it. Okay.
Yeah.
Share my screen, and it is so for full screen. Maybe it is in PDF. So maybe.
Yeah, it can be. Yeah, you can. Yeah.
Visible? This one is visible?
No, this is not visible, sir. You are visible, that's all.
Oh, sorry.
Yeah.
So I share the screen. Here it is. Just a minute.
Hello.
Hello.
Yeah, it's not sharing, I believe.
I shared, actually here is option is not giving me. I shared whole screen, so it should come. Is it not visible?
Not visible.
Oh, just a minute. Now, so this option is here option is inactive here. Why this is so?
No, you can present screen actually here. Possible.
Mhm. I share the screen. The screen should come here.
PDF.
Where
Sir?
now it should come. Is not visible?
No, no, not visible. No, not visible. No. ಸೊ ನರಹರಿ ಅವ್ರು ದುಡ್ಡು ಕಳಿಸಿದ್ದಾರೆ ಅದನ್ನೊಂದು ತಗೊಂಡು ನರೇಂದ್ರ ಕುಮಾರ್ ಅವರೇ ಶೇರ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಕಂಟಿನ್ಯೂಷನ್ ಇದೆ ಸರ್ ಹಲೋ
Hello, yes. Yes, please.
It's not visible here. Can you send it to us so that we will share on your behalf? If you send it to me, I'll share on your behalf.
Yes. Okay.
Yeah. Microphone. Other mute my friend. Other not audio.
Yeah, it is sent. Just can you please check it there? Yeah, emailed. I have emailed it to you. Hello. Did you get the email?
Yes, sir. I'm sharing it.
Okay. Am I audible?
Yeah. Hello, sir. Hello. Sir. You can speak. Sir. Hello, sir. Hello. 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 Dr. Sapkota, you can start actually. Whenever you ask me to change the screen, I'll skip to next slide. Hello, can you hear me, sir? Hello.
Mhm.
Hello. 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 Sir, can you? Hello. Hello.
Hello,
Hello.
hello, hello.
Can you hear me, sir? Can you hear me, sir? Can you
Yes,
hear me?
sir. Yes, sir. Yeah, it is audible.
Yeah, now you can,
Yeah,
now you can, whenever you ask me to change, I will change the screen, sir.
okay, okay,
You can start, sir.
okay. Thank you so much. And sorry for inconvenience. Little bit during the initial presentation. So thank you so much, organizers, for this opportunity to present among the scholars of uh, computational fluid dynamics and mathematics community here. Uh, I would like to have a short presentation on numerical simulation of different ventilation conditions in a naturally ventilated kitchen. So, oh yeah, next please. Hello. Next, please. Okay. Okay. Actually, as I was introduced by Markandesh sir, I was working in a renewable energy project here in Nepal, especially in improved cookie stove project. So I was interested for these topics. Initially, actually, it was started when I was attending a conference at India. Actually, here in Goa, there was a conference in Goa organized by Games, and after that, I started my work on these areas. So we know that air is one of the five essentials: air, water, food, heat, and light. It is found free and pure in nature. So air pollution is the presence of one or more contaminants in the indoor environment that causes to be injurious to human health and welfare, as well as animal and plant life. So actually, indoor air pollution is a function of indoor emission, ventilation, air cleaning efficiency, and infiltration of outdoor pollutants. So out of these four, I will be discussing on ventilation. Next, please. So indoor air pollution represents fourth most important health risk factor after malnutrition, unsafe sex, and unsafe drinking water and sanitation in the developing world. So indoor air pollution causes more than 7 million deaths per year in lower and middle income countries, and especially for South Asia. Yeah, especially for Southeast Asia, it is 2.2 million. It's huge. So Spain also, the motivation is the fact that we spend most of the times, that means more than 90% of the time in the indoor environment. So in the meantime, 9 of the 10 breathe air which is contaminated. That is full of pollution. So vast majority of death occur from LRI in young children under 5 years of age with huge adverse effect on human health. Similarly, 2.7% of the entire global burden of the disease, that is loss of healthy lives due to death or illness, is attributed to the indoor smoke or indoor pollution caused by different sources. So we study the fluid flow distribution in a single room, naturally ventilated kitchen here, with shifting of the ventilations of that kitchen. Next, please. So when we talk about air pollution, especially indoor air pollution, there are so many sources. Generally, we think about the air source of air pollution means smoke coming from stove, or if someone is smoking, then we say that it is air pollution. But there are so many other things also as a source of air pollution, especially for the indoor environment. Like we are dealing with the paint. There are some indoor combustion, building materials, consumer products, biological contaminants, tobacco, incense burning, infiltration of the outdoor air pollution from the windows or doors or any other openings like that. Next, please. So study of indoor air pollution involves mainly emission from some of the sources, accumulation, assessment of the pollution generally attributed due to the poor ventilation or air exchange in the indoor environment where we live. It was actually CFD, computational fluid dynamics, is one of the area which can of the mathematics which uses for the study of the environment, outdoor environment or indoor environment. So wherever there is a fluid, these can be used for the study of the fluid flow analysis. That's why the area of the study has been extended in many areas from the beginning, 1960s, around 1960s, it was only aerospace community. Now the modern CFD is used in all the disciplines wherever the flow of the fluid is important, such as modeling of indoor airports. Sorry. So for CFD, actually, given inlet, outlet, wall velocities, pressure, we need to solve for velocity, U, V, W. I need conservation equations for different unknowns. Actually, for these continuity and momentum equations, there will be 4. But if there are heat equations and equation of states, there may be more. So need to solve continuity equation and momentum equations. Analytical solution of this does not exist since these are highly nonlinear coupled. So only choice is for numerical methods with different numerical techniques. Next, please. So there are many different solution methods. So I will be talking about these Navier-Stokes equations a little bit later on, but just for brevity, I'll be stating here direct numerical simulation, average solutions, especially for Reynolds average Navier-Stokes equations will be most commonly used equations. So we'll be getting extra flux values and mathematical for this mathematical model we'll be using set of governing equations. Just we use incompressible Newtonian flow analysis using Reynolds average Navier-Stokes equations. So for turbulence, we'll be using K-Epsilon model as it is the mostly used and validated model. So indoor space is discretized after making the kitchen model using design modeler of ANSYS Fluent, and the solution method is the simple semi-implicit method for pressure link equations. So results are compared with the experimental data and found in good agreement with each other. Next, please. Next, please. Oh. Next, please. Okay. So here for starting the substantial derivative, actually it is not needed. Divergence of the velocity, we most of the we are familiar with it. Next. So here we'll be using continuity, momentum, and energy equations. These are the equations for continuity, momentum, and energy equations. And later on for turbulence, we'll be getting other equations. Next, please. For closing the equations, we'll be using equation of states. So for three-dimensional numerical simulation, we have a 5 PDEs, and there are other unknowns, P, rho, E, T. So we need others. Yeah. Next, please. Yeah, we can eliminate it. Yeah. So for turbulence, there are actually the linear room air is considered turbulent motion, having turbulent motion. And about the turbulence, Terekes and Lumley define turbulence in terms of irregularity, diffusivity, large Reynolds number, three-dimensional vorticity, and dissipation. So fluctuations will be there in spite of the linear part. So turbulence is considered to be generated mainly from the shear of the main flow, that is primarily streamlines, and also from the buoyancy and external body forces. Next, please. Okay. So this is transport theorem, which is guided for the mobility of the fluid. So total production rate of the total property phi is equal to sum of the contribution from the change of phi throughout the control volume and the net outflow of the phi of the control surface. So these are the forms. Next, please. So for turbulence, the effective viscosity is the viscosity sum of the viscosity and turbulence viscosity. So where L is the length representing the micro scale turbulence, C nu is a constant, K and L may be expressed as a function of the positions, the flow field. So these are the L is equal to C1 K to the power 3 by 2 by epsilon. These were the very initial models and define where it defines the length scale, whereas epsilon is defined in this way, mu by rho, and del u j by del x j and del u j prime by del x j prime. So these are the primes are the fluctuation part. So this mu t is defined as C mu rho k square by epsilon. Next, please. So this is the governing equation, which represents different equations. That is continuity, momentum, k, epsilon, heat equation, and concentration equations as per the values of effective viscosity and source term. Various phi is a source term. The first term represents transient term, divergent. Second is the divergent term, and diffusive term is first term on the right hand side is diffusion term, and next one is source term. So the constants are defined in this way. Next, please. So this is the K epsilon equation we have used. Next, please. So for these are the values of the constant taken in general. Next, please. Okay. First, I think first I'll be just. Can you go, please? Next slide, please. Then I will discuss about these boundary conditions, because model I have to say next sir. Next one. There is a kitchen model. Next one. Sorry. Yeah, okay. No. Next one. Sorry for it. Next one, please. Next one. Okay. We can see the boundary condition. I was interested to see the kitchen model. We can go back, sir. Thank you. Sorry for it, because it is a little bit far and it will be difficult for you to get it. Okay. Actually, for these designed kitchen, we have inlet velocity for the kitchen. Actually, I wanted to show the kitchen. In that case, we have two windows and one vent and one door. So as per the velocity and direction of the air, the inlet air is from the window, and we have taken window velocity and outlet ambient pressure, outlet condition. So temperatures for the walls are also taken, and thermal flux of the stove is also considered, and air density, and no wall boundary conditions are applied at the wall. and temperature of the fluid layer. Wall of the means fluid layer. Temperature of the fluid layer at the wall is considered as T. Okay, next please. I will just show you the kitchen little bit later. Okay. So discretization method of approximating differential equation by system of algebraic equations. Actually, we are familiar with it. So different discrete locations are grid and mesh points, and continuous information from the exact solution is replaced by discrete values. Most of us we are familiar with it. Next, please. So we have used finite volume method for this, and we generated the grid, discretized it, and got the solution. Next, please. So we know that the general form of the discretization is represented by this equation 19, and the other nodes for different nodes. So AP is the central point, and NB are the neighboring points, and B is the source star. Next, please. So for we can get it for different 1 and 2 and 3 dimensional cases. For 1 dimensional case, we can integrate it the first term, and we'll be getting we'll be approximating it by the equation 21. That is first term is approximated by this equation 21, and second and third are also approximated. Next, please. So for second diffusion term also can be approximated by this way. So and source term also approximated in this way. Okay. Next, please. Oh yeah. Okay. So these are the cases for 2-dimensional, and approximations are made by integrating it. For 2-dimensional, we use integration 2 times. For 3-dimensional, we'll be using 3 times. Okay. Phi and C are the scalar and source terms respectively. So these will be solved. The sparse matrix will be solved by the simple algorithm. Okay. Next, please. Yeah. So extra this integration similar approximations are used for these terms, and we'll be getting this equation like 27. Next, please. Yeah, these are the values of the coefficients. W means A. Actually, we are familiar with these terms: east, west, north, south. Yeah, and a point. Okay. Next, please. Yeah. So for 3-dimensional also, we will be using. We can use this integration for volume integration. Next, please. Actually, the process is same, so we can skip it. Yeah. Okay. So as before, we'll be approximating for 3-dimensional cases. Just we'll be getting the volume integration. The equations remain same. Next, please. So there will be different values of the constants, coefficients of this equation. That is discretized equation. So these values are given by these equations. Next, please. The coefficients we can find in this way. We are familiar. So for mesh generation, we use this room. This is discretization of the room. Next, please. So this actually I wanted to show you in the first. so that it would be clear. Little bit, it's here 5. So for experimental, this is the kitchen where these two small windows are here and small vent is here. There are 5 locations inside the kitchen: A, B, C, D, and E. Here you can see just below this B location there is a space here. Actually, I couldn't show you by my cursor. Yeah, yeah. After the next to B, there is a stove here down just below the chimney, but chimney is closed here. Chimney is closed, and C and D are the dining area. C and D are the dining area. B is the just above the stove. There is the location B, and A is just below the vent. Small opening here, and E is the here in the left side. Here you will be getting E, and E is just below the ceiling. Just below the ceiling. These are the 5 locations where we have used these devices. These 3 devices. Yeah. And dimensions are here. Dimensions are mentioned here. And actually, air comes from the side of the windows, and it goes from the door. Okay. So these 3 equipments are used. Next, please. Yeah. The used 5 set of these equipments were used for the study. That was micro-earth to measure the black carbon, and it has a time resolution 1 minute. Similarly, uh, aeroset for total suspended particles of size 1, 2.5, 4, 10 microns, and total suspended particles. Okay, and it has also resolution 1 minute. Similarly, IAQ probe was used to measure CO2, carbon monoxide, volatile organic compound, temperature, relative humidity, and these. And these equipments were supported by EC mode. I think most of you know about EC mode. It is a regional study center, research center from 6 countries, including India, Nepal, China, and others. So I was there working with them as an affiliated researcher, and we had a in remote village. We have taken that kitchen for the study, that kitchen design, and 15 set of these equations. 15 means equipments were used for 5 locations. Okay, next please. Yeah. So for experimental, we have used these different events. So this is the ID for timing: window 1, window 2, and small vent. For ID E1 VO ID, this means evening. E means evening. 1 means first window open. VO means vent open. So this was the case. So here we can see window 1 is open, window 2 was closed, and that vent was also open. Similarly, for the morning, first window was open, vent was open. Okay. For in the evening, second window was open and first was closed. Similarly, for the morning, the vent was closed. So for the evening also, first window was closed and second was open. Okay. So these were the cases, and actually here in this case we have mainly focused on the effect of opening of window 1 or window 2 for the distribution of the indoor pollutants, so that the people or occupant living inside the kitchen would have less effect of the air pollution for the health perspectives. Okay. Then we measured measured the pollution level at these 5 locations, and we have checked it. Okay. Next, please. Yeah. So this is turbulent kinetic energy distribution. window 1 and vent open. This is the case, and window 2 is the right side of this one. So on the front back side there was a slab in the kitchen, as we have seen, and we can see the motion is turbulent, and it was higher in the corners of the windows, and the more turbulence is seen at the door, the corner, right side corner. Next, please. So these are the turbulent kinetic energy seen at the level of 1.1 meter and 2 meter. These are the plates. So while opening window 2, before we had opening of window 1, and this is the case for window 2, and there are 2 levels. Next, please. So this is the volume rendering for turbulent kinetic energy while opening window 2 and vent open. Next, please. And this is here we can see the stove also. So these are the this is the opening of window 1, and we can see the sorry, window 2. We can see there the formation of vortices on the left side, and it has a very less amount of air to dilute inside it. And next one, this right side, you can we can see the level, different level of pollutions here. This was opening E2, E2 open, means that is window 2 opening, and vent open, and these are the cases. And we can see that the pollution level are higher at A. That was at the top of the just above the kitchen, and that is stove. And the C and D are the dining area. Here we will be comparing the pollution level of the C and D later on, and then they are very less, and mainly the A and B, the pollution level at A and B is higher. Okay, next, please. While opening window 1, we see that the opening of window 1 has more reduced the pollution level drastically than that of the opening of the window 2. Next, please. So these are the velocity distribution at the different level above the ground. So here we can see the velocity distribution coming from the vent, the north, this side, left side. Here, next, please. And we can see the formation of vortices in the graph as well. So here we have also compared the pollution level, how many times the pollution level is higher at level A. Especially we wanted to see the pollution level at B and A. Generally B is the just below B is the position of the occupant inside the kitchen. Okay, so here we can see the pollution level, average pollution level at A and BCD. We have taken average of BCD. So from there we can see that the pollution level at A is 1.9, 2.6, 2.8 times greater than that of the occupant level or dining level, dining region, we can say. Similarly, it is for carbon. Similarly, we have seen for 2.5 PM 2.5 at BCD also, and there also we can see it is about 2.5 times more than that at dining region. Next, please. And it is for VOCs, that level, and it is observed that it is more than six times higher is observed at A than that at dining region. Next, please. Okay. So from here, yeah, from that I already discussed about it, and the corners and just a opposite of the stove is maximum 3 to 5 times. The locations of vortices formation have higher concentrations. I have not presented the arrow diagrams of the things here, so we could see from that. So opening of window near the stove instead of window far from the kitchen affects your distribution in two ways. It reduces concentration near the stove and slightly increases concentration in the dining region. Slightly higher concentration is there. Maybe next one is it is also true for other pollutants also. It was also found the same. Okay, next please. Next please. Yeah. Okay. So higher concentration at E, that was E was just below the ceiling. That was the due to convection, lack of dilution of the air, and recirculation of the flow. So analysis of the fluid flow distribution under the condition with two open windows giving cross ventilation is better option. For cross ventilation we have not used, but we have found it for separate. So numerical simulation and experimental verification show that the proper design of efficient ventilation system provides a better quality of the air to the occupant. And also one thing, yeah, next please, we can see from that. Also, actually, this is for coming, and also we have observed that the higher level, the pollution higher level at the pollution level E is also not good for the rural settings where people will have some sitting just above the kitchen. In the rural areas, they have a house, and just above that opening, they will have an opening in the above story. Then that is also not good for them due to health perspective. And this is for upcoming project, and we are working on with Nepal Academy of Science and Technology. And this is here you can see this is the swab collection unit. That is the mobile swab collection unit. And these are the two hands gloves you can see from here. And it is a vehicle. Ministry of Health and Nepal Police and armed police vehicles, they are equipped with these things. We have used HEPA filter for controlling these pollution from outside, and for inside also we have measured the air quality, and we want also to see how the pollution level are distributed inside this swab collection unit. Okay, thank you. Next please. Finished. These are the references, and yeah, next please. Yeah, next. Yeah, next please. Thank you so much for your time. Okay.
Okay, sir. Sorry for the inconvenience caused because we coordinated. My room was like a controlling room. So whenever he asked me to change the slide, I changed it. So I hope it did not cause any problem for the participants. Thank you, sir. It was a very good lecture, a very good presentation. Really, it is the need of hour because in even the Bangalore also is becoming like it is becoming it was supposed to be known as a AC city. Nowadays, because of the greenhouse effect and all, it is becoming warmer. In summer, we also need proper air conditioning and ventilation and all. So really, your lecture, your presentation was very good. It was, I think, it will lead to some more studies. Those who are listening to your lecture, I'll give 2 minutes of time to participants. If you have got any questions, you can ask the questions to Dr. Buddhi Sapkota. Audience, please.
Okay.
Good morning, sir.
Yeah. Yeah.
Dear sir, presentation was very nice. As said by one of the coordinators, the talk is definitely need of the hour. So we are really grateful to you in delivering the talk, faculty development program. Thank you very much.
Thank you so much.
Thank you, sir. Sir, I think
Okay.
I told you a lot because I made you to come
No,
all the
no,
way to
sorry,
Kathmandu.
yeah,
He
yes.
actually he went to his native to celebrate Diwali festival. Because of the lecture schedule, he rushed to Kathmandu and he gave the presentation. He presented his paper. So very nice of you, sir. Thank you, sir. Thank you for
Thank you so much
your
for
nice
this.
presentation, sir.
Thank you, sir. Thank you so much. And we will be having coming days of you. Thank you so much. Thank you. Okay.
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 Hello. Now, for the next session, it is going to be computational, the basics of computational, introduction to computational fluid dynamics by Narendra Kumar of Jyoti College of Engineering, Jyoti Institute of Technology, Bengaluru. Please join us at 11. 10 minutes break you take. Join us at 11. Thank you.